Hello coders, I welcome you all. In this video, we are going to discuss the confusion matrix. Can you see these images? For us as humans, it is sometimes difficult to classify images when they are given like this, right? We get confused when classifying these images. So it is very difficult for machine learning and deep learning algorithms as well. If they receive images or data samples that are very similar, they become confused regarding such classifications. If we want to check this confusion in machine learning and deep learning models during classification, we can use a confusion matrix. A confusion matrix shows where our model is confused and where it made mistakes in the classification task. Using a confusion matrix, we can derive evaluation metrics like accuracy, precision, recall, and F1 scores. They help us to evaluate the performance of machine learning models, specifically for supervised learning and classification tasks. In this video, we are going to discuss the confusion matrix for binary classification. If you can understand this, you can understand the confusion matrix for multi-class classification as well. In binary classification, there are two possible target classes, which are typically labeled as positive and negative, or 1 and 0. If we take the most common example of binary classification, email spam classification, ham means not spam is considered the negative class, while spam is considered the positive class. In this video, we will perform reverse engineering. We are not going to discuss formulas. Instead, we will focus on grasping the concepts first. From these concepts, we will formulate equations. So let's get started. You can see here how the confusion metric looks in the case of binary classification. So assume that our dataset contains 100 samples and our dataset is balanced, meaning we have an equal number of samples for positive and negative classes, both having 50 samples each. And here you can see 1 and 0. 1 and 0. 1 means positive, 0 means negative. In our case, 1 means spam, 0 means not spam. And here you can see actual values and here predicted values by our model. So out of the 50 positive samples, 40 are correctly predicted as positive. These are actually positive. So they are called true positives. Out of the 50 negative samples, 30 are correctly predicted as negative. These are actually negative. So they called true negatives. Among the 100 samples available in our dataset, our model classified 10 as negative, but they were actually positive in our dataset. So this is referred to as false negatives. Among the 100 samples available in our dataset, our model classified 20 as positive, but they were actually negative in our data set. This is referred to as false positives. Hope all of you are clear with true positives, true negatives, false negatives, and false positives. Now let's move on. As you can see in our confusion matrix over here, the false positive rate is higher than the false negative rate that you can see over here. False positive instances are 20 and false negative instances are 10. So here in our confusion matrix, false positive rate is higher than the false negative rate that you can see over here. This is just for your information. So in the binary classification, the goal is to increase both true positives and true negatives while minimizing false positives and false negatives. I am repeating, in binary classification, the goal is to increase both true positives and true negatives while minimizing false positives and false negatives. So based on these four values, we can evaluate the performance of classification models. And classification matrices are derived from these values that we will discuss shortly. As you can see, in this table, actual and predicted values are provided. From this, we have to determine the four values: true positives, true negatives, false negatives, and false positive. As you can see here, actual value is 1, but the model predicted it as 0. So it becomes false negative. So you can pause this video and try to complete this table as you can see over here. Now you can compare your result with this table. Hope all of you are clear with four values: true positives, true negatives, false positives, and false negatives. Now let's move on. Now let's discuss accuracy first. So accuracy represents out of all the samples available in the dataset, how many samples are correctly predicted. You can see here, these samples are correctly predicted. True positives and true negatives. I am repeating, accuracy represents out of all the samples available in the dataset, how many samples are correctly predicted. That you can see over here. These samples are correctly predicted. So we can calculate accuracy by taking the ratio of correctly predicted samples to the total number of samples available in our data set. That you can see over here. These are correctly predicted samples, 40 plus 30, divided by all the samples available in our data set, 40 plus 10 plus 20 plus 30. So output is 70 by 100. So the model's accuracy is 0.7 or 70%. So now from this knowledge, you can easily derive the equation for accuracy, right? So as I said, accuracy means out of all the samples available in the data set, how many samples are correctly predicted. So we can write equation for accuracy like this: TP plus TN, our correctly predicted samples, divided by all the samples available in the data set. So TP plus FN plus FP plus TN. So this way we can calculate accuracy for our model in case of binary classification that you can see over here. Hope all of you are clear with accuracy. Now let's move on. Now let's discuss precision, recall and F1 score. So please remember, precision, recall and F1 scores are calculated class-wise per class for the positive and negative classes separately. Please remember this. I am repeating, the precision, recall and F1 scores are calculated class-wise for the positive and negative classes separately. But please remember, in the case of binary classification, precision, recall and F1 scores are often interpreted in the context of the positive class. I am repeating, in the case of binary classification, precision, recall and F1 scores are often interpreted in the context of the positive class. But we can calculate precision, recall and F1 scores for the negative class as well. Just remember, precision means prediction by our model. P2P, precision and prediction, means out of all the predicted instances for the class, how many instances are correctly predicted. Please remember, here we are calculating precision for positive class only. So we can say like this: out of all instances predicted as positive, how many are true positive? That you can see over here. Again, I am repeating, precision means predicted by our model P2P. Please remember this, P2P means out of all the predicted instances for the class, how many instances are correctly predicted. Now let's calculate precision for positive class, this one. So you can see here, out of all the predicted instances for the class, how many instances are correctly predicted. So these instances are correctly predicted, 40. So we can calculate precision like this: 40 divided by all the predicted instances, 40 plus 20. So which is 40 divided by 60. So the precision is approximately 0.66, means around 66%. Now from this knowledge, you can easily derive the equation for precision, right? Please pause this video and try to derive the equation for precision. So precision means out of all the predicted instances for the class, how many instances are correctly predicted. So TP, which is correctly predicted instances out of all the predicted instances, TP plus FP, right? So this way we can calculate precision for positive class. As I said, precision, recall and F1 scores are calculated class-wise per class. But in the case of binary classification, precision, recall and F1 scores are often interpreted in the context of the positive class only. But As I said, we can calculate precision, recall and F1 scores for the negative class as well. That we are going to do next. We are going to calculate precision for the negative class as well. So please pause the video and try to calculate precision for the negative class. As I said, precision means out of all the predicted instances for the class, how many instances are correctly predicted. But here we are calculating precision for negative class. So how we can say the definition? Out of all instances predicted as negative, how many instances are true negatives? So these instances, 30, are correctly predicted out of all the predicted instances for negative class. So we can calculate precision of negative class like this. 30 divided by 30 plus 10. So 30 divided by 40. So the precision for negative class is approximately 75%. So now from this knowledge, you can easily derive the equation for precision for negative class as well. So Tn, true negatives, divided by all the instances predicted as negative, Tn plus Fn. So this way we can calculate precision for negative class as well. So now let's move on. Now let's discuss recall. Recall is also called sensitivity or true positive rate. Now let's discuss general definition of a recall. Recall means out of total instances for a class, how many instances are correctly predicted. I am repeating, recall means out of total instances for a class, how many instances are correctly predicted. So as we discussed earlier, precision, recall and F1 scores are calculated class-wise per class for positive and negative classes separately, right? So as I said, in case of binary classification, precision, recall and F1 scores are often interpreted in the context of positive class. So now let's calculate recall for the positive class first. Then we will calculate recall for the negative class as well. So in the case of positive class, recall means out of all the positive instances in the actual data set, how many instances are correctly predicted by our model. So this is the part. Again, I am repeating. In case of positive class, recall means out of all the positive instances in the actual data set that you can see over here, 50, how many instances are correctly predicted by our model. Here, 40. 40 instances are correctly predicted out of all the positive instances available in our class, positive class. So we can calculate recall for the positive class like this. 40 divided by 40 plus 10 is equal to 40 divided by 50. So the recall for the positive class is 0.8 or 80%, right? So from this knowledge, you can also derive equation for recall as well. So we can write equation for recall like this. Tp divided by Tp plus Fn, right? So this way we can calculate recall for the positive class. Now let's calculate recall for a negative class. As you know, the general definition of a recall. Out of total instances for a class, how many instances are correctly predicted. So for recall for a negative class means out of all the negative instances in our actual data set, how many instances are correctly predicted by our model, means this part. So we can calculate recall for a negative class like this. Please pause this video and try to calculate recall for a negative class. So we can calculate recall for a negative class like this. 30 divided by all the negative instances available in our actual data set. 20 plus 30 equal to 30 divided by 50. So the recall for a negative class is 0.6 or 60%, right? So from this knowledge, you can easily derive the equation for recall for a negative class. So we can write equation for recall for a negative class like this. Tn divided by Fp plus Tn. Hope all of you are clear with recall. Now let's discuss F1 score. Please remember, false positives are called type 1 errors, while false negatives are called type 2 errors. Now let's discuss F1 score. Please remember, there is always a trade-off between precision and recall. When one increases, the other decreases. Therefore, it's better to use metric that combines both precision and recall into one value. This metric is F1 score. The F1 score is useful when both types of errors, type 1 means false positives and type 2 false negatives, are significant. F1 score combines precision and recall into a single value. The F1 score is calculated using harmonic mean of precision and recall that you can see over here. F1 score is equal to 2 into precision into recall divided by precision plus recall. So these are the precision and recall for the positive class that we calculated earlier. You can see to calculate F1 score, we required precision and recall for each class. So you can understand that the F1 score is calculated class-wise per class, right? So this is the F1 score for positive class 0.72 means 72%. However, as we discussed in the case of binary classification, we consider only the positive class. If we required, we can calculate for the negative class as well. So try to calculate F1 score for the negative class and write calculated F1 score for the negative class in the comment section below. Hope all of you are clear with F1 score. Now let's move on. So you are wondering why accuracy is not enough to evaluate the performance of machine learning algorithms, and why should we learn other performance metrics like precision, recall and F1 score, right? So accuracy is not a good metric in the case of an imbalanced data set. So what is an imbalanced data set? An imbalanced data set occurs when one class has many more instances than the other class. Let's consider a binary classification problem where we want to predict whether an email is spam or not. We have a data set of 1000 emails, of which only 50 are spam and 950 are not spam emails. So as you can see here, assume that we are creating a classifier that always predict not spam, the majority class only, regardless of the input. Means whatever input you give to our classifier, it always predict not spam. Since only 50 out of 1000 emails are spam, this classifier would achieve an accuracy of around 95%. Because you can see 950 out of 1000 emails are correctly classified as not spam. However, despite the high accuracy, this classifier completely fails to detect any spam emails. Even you can see in this case, the precision is 0 and recall is also 0. So we can't rely on an accuracy if our dataset is imbalanced. As you know, an imbalanced dataset means one class has a higher number of samples than the other class. For an imbalanced dataset, we have to check other metrics as well, like precision, recall and F1 score. Now let's move on. In machine learning, we have to handle various problems. So domain knowledge is also required. Depending on the problem, we have to choose the appropriate model regardless of its accuracy. Accuracy is a general measure of a model's performance and does not provide detailed insights into the specific types of errors, which is important in many cases. So let's assume that we are performing email spam classification and we have used two machine learning algorithms. Here you can see the confusion matrix for the two classifiers. Now we need to choose which one to use. Please pause the video and tell me which one will you select. For email spam classification, a higher precision model is crucial because it ensures that legitimate messages are not incorrectly classified as spam. So here false positives are important. So as this could result in important communications being missed. For instance, if someone is waiting for a placement email and it goes to spam, they might miss important deadlines. But receiving spam emails in the inbox is manageable since we can delete them. But missing important emails due to false positives can have serious consequences, right? So from these two models, you can see that the second model has a lower false positive rate. As I said, here we have to check false positive rate. So we should choose second one. that you can see over here. So you can see, even though both models achieve the same accuracy, we choose the second model because it better suits the nature of the problem that you can see over here. Here we are choosing model with higher precision that you can see over here. This one, second one, with precision of 66.66% that you can see over here. So again, remember this, here are actual values and here predicted values, same that we have discussed over here. Like this only, actual and predicted values. Now next, let's consider another scenario. Assume that we are performing a project for disease classification, determining whether a person has a disease such as cancer or not. Here you can see the confusion matrix for the two classifiers. Now we need to choose which one to use. In this case, a higher recall model is important because recall matters. Here we have to check false negative rate. So we need to reduce the false negative rate because if a person has a disease but our model predicts no disease, it can be very dangerous to their health. However, if a person doesn't have a disease but our model classifies them as having a disease, they can undergo further checks and confirm their health status, right? Therefore, we need to reduce the false negative rate here and select the model with higher recall. Pause the video and tell me which model you would select. Since you can see here, the first model has a higher recall, we should choose it, that you can see over here, this one. So again, here, even though both models achieve the same accuracy, we choose the first one because it better suits the nature of the problem that you can see over here. Hope all of you are clear with this. Now let's revise. First, accuracy. Accuracy means out of the total instances available in our dataset, how many are correctly predicted. Now, precision. Precision means out of the total predicted values of the class, how many are correctly predicted. As we discussed in a binary classification scenario, where there are two classes typically labeled as positive and negative, precision is often interpreted in the context of the positive class. So if we consider this, then the precision will be out of all instances predicted as positive, how many are truly positive. Now, recall. Recall means out of the total values of the class, how many are correctly predicted. Again, if we consider binary classification scenario, recall is often interpreted in the context of the positive class, right? If we consider this, then the recall will be out of all actual positive instances, how many were correctly predicted as positive. Now F1 score, which is harmonic mean of precision and recall, which provides a balanced measure of a model's performance. Again, F1 score is calculated class-wise per class. Hope all of you are clear with accuracy, precision, recall and F1 score. Hope you like this video. Please don't forget to subscribe this channel. If you like this video, smash that like button. Thank you very much for watching this video. Take care. Bye-bye. See you in the next video.